log data available publicly. So what I've done is I've created a public database already with some interpretations in it. And let me give you that link so if you have it. But what I've been doing, I think it's this one here. We need to, we have a couple problems with this database. One is that I need to get in there and extract wells from it because we had a guy that was working for us before that was using that database to do work for a client. So there's a whole bunch of wells in there down in Upton County that belong to the client, right? And we have to remove those from that database because it's not, it's not appropriate to have those in there. We need to get rid of them. I know which wells those are, but I have to go in there and delete them and, copy them out or whatever. But the wells, just my solid comment would just be stay out of Upton County because that's proprietary data down there. But everything else is fine. So you got wells that are up in, let me just open that thing on my computer here. I'm trying to do like save wells database. Trying to do a couple things at once here. I got to close these things out from yesterday with this grant database that we did for the Daniel presentation. Just give me a minute. It's saving all 163 of the wells. Okay. Almost done. All right. Okay, so let's look at that public Permian thing. And I'm giving a moment here. Oh, geez, okay. Why this is so slow. So all this stuff down here in Upton County, just stay out of there because those things are, this is where Alex is working. I wish he would have never have done this, but he did this. He created a huge mess for me. I ended up firing him. Fucked the whole project up. Anyways, the rest of these wells are all public. I just downloaded them off the internet. Okay. You've got stuff all over the place too. You've got stuff up on the Central Basin Platform. You've got stuff in the Midland Basin. You've got stuff all the way over here. Various amounts of data. Some of these wells I've actually gone through and interpreted because I need something for a paper, right? If I'm publishing something or whatever, I'm giving a presentation, I have to have some data set to use. So like these 3 wells I used for something, I can't remember what. If you see an F on them, you'll know that it was completed, right? And if you look at the interpretation, this is standard, petrophysical things that we do. Nothing out of the ordinary here. The only problem is for some of these wells, we don't have all of the wonderful calibration data that we often have from a client, right? The client's got 4 and advanced log suites and stuff. So what you'll have to do, it's one of them things, right? We want to make sure that our petrophysical interpretation is as good as it possibly can be, especially if we're going to go down that road of doing machine learning and then assessing how well the machine learning fits. So for example, like these 3 wells, I interpreted these things on a weekend, right? Like when I'm doing a paper, like, this is not paid work. So I just really quickly, I just spent a few hours or whatever to burn through these things. I can tell you already that there's problems, right? Like this well doesn't look too bad. just the data quality of it, the caliper and all that, right? Like you can see what the lithology looks like. Sorry, this well I think is okay. The Arco Wyndham well doesn't look too bad. I mean, there's some zones in here that, they're pretty washed out. And I've got some high porosity here, for example, in the Sprayberry. Like I'd be very skeptical that this is good data. Like you're probably gonna have to make another pass and come through here and edit this a second time, like we were talking about last night. Get that sorted. But it's reasonable looking. And then you go to the June Tippet, and all of a sudden, look, I've got all this dolomite. And if you look at it, where's the dolomite showing up? It's showing up where I have washouts, right? So, this data, there's problems with this data, one way or the other. And, that's where you kind of get to this, where's that? This thing, and you start looking at these. So let's just look really quickly here. I don't know, I'll just shove something in there. So we'll do that, neutron, PE, resistivity, bulk density. Use a log on that. Take the tops, select all the tops, check them, correct them. There you go. So, like, first of all, I can already see that there's some issues, like Joe Mill in one of these wells has got some goofy looking neutron, right? And if I come back over here and I was looking at this thing, gee, that's the Joe Mill. Look at the washouts, look at the dolomite. How much you want to bet that bright spot right there is that June Tippet well, right? Mm-hmm. And you start looking at these things too, like Joe Mill, right? We were just talking about that. So sonic data, looks fine. Gamma ray, June Tippet looks like it's a bit low, right? And that would be consistent with washouts. So, again, if you came in here and you did environmental corrections and you put that, I think it's maybe I already did that. Did I already do that? Already got it in there? It's already in there. So if you plot the environmentally corrected gamma ray, why do we have to play these things? So you can see there is a difference, right? Like it's 94 to 79, and that may raise it a bit. But even still, even with the environmental correction, maybe it needs to be normalized because something's wrong, right? I don't think. I mean, it's possible there could be some slight changes because that's a little bit more towards the platform, but I'd expect that to look very similar to the Arco Wyndham. Those are basically right on strike with the deposition that's coming there, right? So there's something wrong there. And if I look at neutron, that June Tippet well is a bit on the high side. If I look at bulk density, there is the smoking gun right there. There it is. So one way or the other, what ended up happening was because of that washout, even though we edited the density, we still didn't get it right. Still wrong. And that shows you that, So yeah, these would need work prior to machine learning, right? Because otherwise we're training a model on garbage, kind of. So that's my only concern with this sort of project. So you have to make sure that you go through these wells and kind of, and the problem with it too is like the rest of the wells, we've got a whole bunch up here or something. A lot of these I haven't even classified, like if they're like a G question mark on them, I don't even know. And if you go look at if you sort it by UWI, it sorts it by that classification scheme that we're using. So you can see if there's an F on something. The other thing too is like if there's a 2, right? That means we've got NMR data, which is great because those wells, like they're all, be careful with all these because these are probably wells that belong to that client that Alex put in there that he should have never put in there. But But, you know, these wells here, all these ones I've got selected pretty much, I'll just load these. No idea where they are. I'll get rid of them. I'll get rid of them. I know which ones they are, but Alex should have never put them in there. So these wells that I've got loaded here, these all have, you know, some of these have NMR. So that's really good because we can calibrate the total porosity and stuff, and we've got a much better. I think maybe even some of them have interpretation. Just look, doesn't look like it. Yeah, very limited data coverage here though too. Right, just a couple of formations. This Hecker well already did this, so this should have an F on it. I don't know why it doesn't. Pretty good data. That's a good one for training, but it's got synthetic sonic in it. So, you know, there's some issues there, and I still think there's some issues with the interpretation because look at all this dolomite, and I'm not matching my total porosity. There's something wrong here with clay parameters, clay volumes. You have to look in here and play because this is that public database. Again, like I have not spent a lot of time to go through these, you know, and whenever you got something off, like that particular zone is a Wolfcamp C. So down here is the Wolfcamp C, like, you know, looks like I've got pretty decent computation on clay, but for whatever reason, it's putting all that dolomite. I know that dolomite is not there, right? So, yeah, like I mentioned before, the way that you deal with that, like I think this is the C here, right? I come in here, I look at this, well, yeah, adjust the parameter, make it more dense, right? Okay, I just did that. And then like, what you have to do is you have to rerun this clay parameters program so that it spits out those curves again from that when you change it. And then I come back in here and I run Mineral Solver again. And then you'll see, watch this dolomite here. Goes away completely, right? And now all of a sudden I've got a better match on my porosity. So, you know, so whenever you're seeing this, Wolfcamp B, same problem, right? So I come in here, I go to the Wolfcamp B, and I just increase that grain density, that clay density. Okay, I got to rerun the program, and then I'll rerun this. Yeah, porosity's better, dolomite goes away, so forth and so on. And it seems like that's an endemic. Even up here in the Sprayberry formation, something's going on, right? So Sprayberry clay needs to go down, probably there. Rerun that. Rerun that. Dolomite gone. Porosity better match. Magic, right? Yeah, yeah. Woodford, I've got the opposite problem where I've got porosity too high, right? So same thing, right? Now we're talking about doing this, actually moving that endpoint up instead of down, rerunning this, and then rerunning the Mineral Solver, and it kind of changed it a little bit. But actually, what needs to happen there is beyond that. That needs to be split, actually, which I already did apparently, but I didn't do it good enough. You can see this density stuff, high density, low density. There's a fractionation that's happening there. So I guess that's the low density stuff. This is the high density stuff down here at the bottom. So there's problems with the Woodford models, though, in general. Like, I think there's some. It's putting that limestone in there, but there's actually no limestone. And if you take that out, like things get a little bit different, and look, you just look at the neutron and stuff too, there's some new stuff going on resulting in that, but not too terribly worried about that because, and the Devonian, right? We're sort of missing on the porosity down there too. And it's mixing dolomite and stuff, and we can fix that. But if we're gonna train, we need to make sure that all this training data is fixed up the best we can get it. This ain't bad, but we can do better, right? You have to clean it a little bit. And you'll have to do this. I'll save this, by the way, so you don't have to. But you'll have to do this. Hold on one second. I got this fucking thing chewing up all my memory. I've been having, like, I've got weird grid resolution problems on this thing. Like, this is what that fracture is supposed to look like, right? The geometry comes from the slick water that I'm pumping, and like it looks perfect. It looks the same as what's coming out of StimPlan, the commercial reservoir simulator. What's supposed to happen at this point, I go to crosslink gel, right? And what's supposed to happen is the fracture screens out because there's proppant in here as well. And it locks the geometry and then it starts to build width. But instead of what happens is it just starts building geometry. And you can see like the proppant in here as well is like kind of fanning out in these sweeps. Like a whole bunch of it comes out, then it just blows it away, right? And it's screening out at the tips, but it's never stopping the fracture from growing. So there's something wrong with the code. I have to keep playing with this. Like StimPlan, basically, as soon as that proppant hits, it bridges that thing and it can't propagate it anymore. But this one keeps growing. But anyways, I would definitely look at building a data set here, and then let's see. I'm gonna do this. So we got this Jeffrey 1W, Jaffrey. So this looks like there's no tops in here, I don't think, or anything. Like you're gonna have to play. This one's got ECS as well by the looks of it. But doesn't have sonic, right? So you have to create a synthetic sonic, which sucks. But if you've got ECS, that's nice for mineralogy calibration, which you do. These two wells, I think, are shallow wells. Yeah. So this is like it just goes down, and this is a carbonate dolomite system, right? And both of these are the same. But this is another endpoint if you wanted to do like machine learning stuff and understand what happens if I build one model from all the data and then start benchmarking it against stuff on the platform versus stuff in the basin. What happens? How bad is it, right? And this thing has got like a partial Wolfcamp at the bottom of it, but it's missing all the upper section. Basically, Wolfcamp A down, all the Dean and everything else above it is gone. And we can always find more data too. It's the same thing, University 37. This is, where's that 37? That's right here on the platform. That's probably a pretty good one. And then that Brenda Dorcas well, that thing I think is limited. Yeah, so this is just gonna be like Wolfcamp B and strong or something. I don't even know why. Oh, Wolfcamp B, I guess. It's quite odd. But we can look on the Texas Railroad Commission website as well to download more LAS files if you can find them. I'll send you links for that. How to dig on there. But we've got, you'll have to look through this data, right? Like, and you'll have to interpret the wells also and clean them up. Some of these things are probably, I would start in the basin actually, and just go all over the place, like all these G7s. These are probably all good wells with sonic, actual recorded sonic data. Let's check these out real quick. Heidi, Walker Glass, and Raven. Map is a piece of shit, man. Yeah, that's a nice big section there, right? Yeah. And then a Walker Glass. Yep, another one. Raven. So those are three good wells. That's Wolfcamp D. There's A, there's D, it's your lower Sprayberry, going all the way through the Clearport and up into the Glorieta, and San Andres starts right here up to the Grayburg. You got dolomites, that neutron density separation right here, that's all dolomite. Type limestone there, or denser limestone, and dolomite. And then you got this sand system right here, sort of dirty sand. And you got the lower Clearport Shale, washed out, of course, clay rich, organic rich. And you go straight into the Sprayberry and stuff. And go down. But yeah. So I will I'll close those, I guess, save them. What the hell? But that's that for you. Yeah, you're gonna want to have a data set to work with that's got a lot of interpretations to measure variance and error and stuff across the wells. The other thing that we can do is trying to think, maybe, well, we'll look. Sorry. At one point we were talking about subscribing to like one of these LAS services, like Enervis has got something. Somebody else was trying to sell us something. TGS, Best was looking into it. I can have somebody else look into it. And they had a cheap option where we could get a bunch of LAS files, and they didn't charge a whole lot, but there was like an expiration date on them or something, like you own the data for 3 years and then you have to delete it, or I don't, like, that would be an option, but otherwise buying LAS data is very expensive. Yeah, it's like $500 or $1,000 US per well, type of thing. So we also have, I wrote a little program that does digitization of TIFs. So you could digitize the logs yourself if you need to. Okay. So we do have software to do that. It's not as good as Noralog, but like in a pinch, the reason I have it is like we get in a project or something, which we've done before with clients, and we need to digitize just like one file or something, right? We could do that pretty quickly and easily. Anyways, yeah, think about it, right? Look at some of the data, start thinking, and let's formulate a plan and get you something that that you're interested in, that we're going to have a well-defined project. We want to have something that's got deliverables and stuff that makes sense, that we can evaluate. So lots of opportunities. Yeah, there's lots of opportunities here. And think outside of the box as well with some of this, because there's a lot of things that we're not doing, that are out there. And I thought about this before too, like, I haven't thought it all the way through, but I've thought about it. For example, right now we're kind of stuck in this world of logistic regression. Well log data, array data, that's pretty much the only sort of machine learning that you can apply to it because of the nature of the data, right? All we're doing is running regressions, really, just fancy regressions, right? And I've always wondered, just kind of thinking outside the box, like, about TensorFlow and some of these other pieces, right? That they've been using for images, like image recognition, right? And image recognition with TensorFlow, I don't know all the details, but I have read about it and played with it myself a little bit. And the way that I understand that it works is that you kind of decompose everything down into arrays, right? You kind of decompose an image down into a flat array set, and then you train on that stuff. So, for example, just saying, what if we created images? We created, a JPEG or whatever, a synthetic image out of well logs. So if you just think about it as a matrix, you've got columns and rows, right? Your rows would be depth, and your columns would be the different curves. You'd have gamma ray value, you'd have a bulk density value. You could normalize these things from 0 to 1, and then assign them fucking color, like 0 to 255 for RGB or whatever, right? So you got gamma ray, bulk density, neutron, DTC, PE, resistivity, something like that. That's what, 1, 2, 3, 4, 5, 6 columns by many, many rows. It'd be an image that's like really long, but that's how TensorFlow does it, right? And what they'll do is they'll just chop it, right? And they'll rearrange it so that it's got the right structure. So we could do the same thing. We could take logs, create images from logs using Python or whatever, and then try to train TensorFlow models to pick up. You would train it just like somebody has a fucking picture of a monkey or whatever, right? Like Lung Uan from Lopburi, right? They have the monkey. They tell it it's a monkey, and they do this enough times, and it learns that how these 2D arrays or whatever are laid out, that that's a monkey. We could, yeah. What if you did something like that and you said, here's a reservoir, here's oil, and then you just trained it, and here's water, here's a wet sand, here's a oil bearing limestone. You trained it on the log responses, the synthetic images of the log responses, right? And trained it, and then gave it raw logs and see if it was able to actually do the prospecting for you and predict what the things are. I think that would be really fucking cool paper to present and write on, that I've not heard of anybody else doing ever. Yeah. 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 What do you think? That sound pretty cool? Well, yeah. Well, that's something though that we may be able to get around too, though, because when you're presenting stuff, like I could probably get permission to use Diamondback data for that, right? Like if we just train the model and use it internally for them. And then, your project essentially would be using the client data, but it's okay because we'll get permission from them to do that. But, I'm just thinking, like, how cool would that model be if it's able to pick tops and stuff too, right? Based off, like, you tell it, this is the top. Just, stop with the original thing I said. Just start with tops. This is the Joe Mill. This is the Lower Clear Fork Shale. This is the Grayburg, San Andreas, whatever. You train the fucking model to recognize the intervals, and then it picks the tops automatically for you. That's like extremely fucking powerful and useful and high value, right? Well, I think that's a home run if you can, and even if you can't get it to work, that's still a paper to publish, right? Like, hey, we tried doing this. This is where we ran into problems or whatever. Maybe somebody else will pick the work up in the future. But I think it will work personally. I think what we need to do is just include enough information in the array that it can figure things out, and uh, maybe we try different approaches, normalized data, non-normalized data, right? Uh, you've got caliper, D-row, and stuff like that you can add in there as well. And it'll learn from that. And, we just looked at this presentation the other night. Some of these intervals, like the strong, are always washed out everywhere. So, like, that tells the model, too, information that it can use to help delineate. So, I think it's worth pursuing something like that. You can do the machine learning stuff with the regression and public wells and play with that as well. But I think if you worked on this as a secondary project or something and looked at creating these synthetic, images from log data, essentially, there's something to be had from that. I don't know what it is yet. Maybe TensorFlow is not the right answer. Maybe something else is. But I think, because people ask for that all the time, right? Well, we want automated tops picking. Like, it's difficult to identify intervals and pick tops. And you've seen what happened the other day too. Like, we had one well in Daniel's data set from way up northeast in like Borden County or something that had the wrong tops picked on it, right? Like, grossly wrong. Like they were like 5,000 feet off depth. So again, if you train that model and it's able to recognize these things and assist you, even if it's not correct, but it's 80% correct, that's massive. That's a huge paper to publish. And yeah, everybody's going to be really interested in that, right? And then what we do is we program it up in our software, and then we can sell our software and make money, right? Yeah, that's what we want to do. Yay! Well, let's pursue that, I guess, then, and that'll scratch all the itches that you've got, because you'll be doing petrophysics stuff, you'll be working with machine learning, you'll be working with data analytics and stuff, and you'll be doing something, like I say, as far as I know, is pretty novel and nobody's tried yet. So I always wondered, we got all these really powerful image classification things that people are using. And fuck, out of all the AI stuff, like I told you, I think already, I got a ticket from these Australian bastards, right, with their AI camera, that caught me using the phone while I was driving. Well, that stuff is working brilliantly on like pixelated, not very sharp images, right? Um, why wouldn't it work on images from logs? It should work really well. If they can figure out from an AI camera that I was on the phone, the bastards, right? We should be able to tell what the Lower Clear Fork Shale looks like. Yeah. Well, the big thing that I don't know how to do that you'll need to learn, and I've tried this with large language models before, like Olama, setting up these prompts and stuff, is how you teach it. Because for that sort of thing, you need to tell it. You need to feed it training data, and you need to feed it like the answers. And I think maybe the easiest way to do that is just to provide the formation tops by depth. But you gotta like translate that to how you create the image, like pixels and rows in the image or something. But how do you? That's something you'll have to research. And the question you need to answer is, how do you, train the model to tell it that's Clear Fork, that's Sprayberry, that's Middle Sprayberry. Train it over and over and over again, right? And then correct it. Like there's a process that these guys go through, right, where they have the model try to predict something, and then it says, you know, pizza or not pizza, and it says pizza, no, wrong, right? And then it learns from negative, false positives and stuff. So we need to do the same thing. Like show us, what you think the Clear Fork is, and we may have to like, translate back and forth between the format that the thing uses and actual log data so that we can understand it, right? Like, and go back and forth. But anyway, think about it, right? See what you come up with. I think that's a cool project. Okay, cool. Yeah, there's more stuff out there too. Check out Stanford's offerings. They've got a number of decent machine learning courses, and trying to think of who else. I don't even know who's like this. The stuff that's in the industry, I would never turn you to at all. I wouldn't recommend it, like because I know the fucking people that are teaching the classes, and they don't know a damn thing about what they're even teaching, right? Like I think Saga, Wisdom, Dave Anderson and John Thompson's training thing there. They've got like Cameron Snow teaching their machine learning and petrophysics and classification classes and all this stuff. And Cameron, like I worked with Cameron, I know Cameron. He doesn't know a fucking thing about machine. I know way more than he does, Uh, and I'm not, a guy that's teaching this stuff to like software engineers at Google. That's the guy who's doing that training. That's where you want to find out where it's coming from, and you want to find courses from that, right? Because those are the guys that are the oil and gas industry and stuff, right? They're just dabbling, and everyone's an expert now because everyone knows Python and everyone knows what a fucking decision tree is, and but if you really want to know machine learning inside out, you got to find the people who are training the Google engineers and the Anthropic engineers and stuff like that. And there's got to be some professors in schools that are doing that specifically for those big Silicon Valley companies in California. And then once you figure out who that is, figure out what the university is, they probably have online courses. So then you're actually taking a course that's being taught by someone that knows the shit, versus Cameron Snow or some other equivalent of Cameron Snow, who's like, we call them, what the hell do we even call them in English? Like one trick pony or a fucking, these cowboy type guys that they're they're experts when they're put in front of a group of people that don't know anything, right? But if you put them in front of a group of real experts, they're no longer experts. You know what I mean? Yeah. Well, like I say, somebody's teaching ML courses for these big companies, and that those are the two that I would focus on is Google and Anthropic. find out who teaches them, have that university teach you, you know? Yeah, and look into you know, what's out there too with some of these other, like, see, yeah, I guess TensorFlow and these other things are these huge convolutional neural network deals, right? So I don't even know what's out there. There's what, PyTorch or something, and a whole bunch of different platforms and options to feed this petrophysical image, false created image data into, you know. I'm sort of excited about this, to be honest, because I think if you can get this thing to identify formations and pick tops, like, man, that's so cool. Yeah, well, then you just take it to the next level and then you start telling it, you know, oil reservoir, gas reservoir, you know, and have it look for stuff. And then that's when you start working with a client like Diamondback, where we start giving it more data. So it's not just log data that you're throwing in there now. You're throwing in geochemical fingerprinting data like from Revochem, and you're putting in their production data and other stuff to see what it can learn, what you can teach it, what it can identify. Because that's one of the biggest things. I think you sat in a few of these meetings that I forwarded to you with Doug and stuff, you know, when he's talking about, um, you know, all these different problems that they're facing with well spacing and production not being the same from all the lateral wells, you know, like these horizontal wells. Some of them are good, some of them are bad. They're trying to understand why. And there's so many different variables going on between the way the wells were completed, where they were drilled, what kind of offset production you've got. Um, you know, like if the wells have neighbors or not that were fracked before, or if they got frack hit after. Like, again, what if you created an image with all of that information as binary yes or no's or something, or values on a column by row basis, you know, somehow figure that out, and then tried to train it to, you know, an answer of some sort. Like, maybe the answer is just some gross metrics from the production data. Like, this is a wet well, this is a not wet well, this one's got a high GOR, this one doesn't. And then see if you can get that thing to predict, you know, based off of a particular configuration or whatever, what's going to happen, right? Like, here's the logs, here's this, here's that. Okay, is this going to be wet? Is this not going to be wet? The EOR thing that they've got, that's massively high impact. Diamondback would be extremely grateful if we could help them with that. Same thing, you know, they're doing this EOR work. If you even want to call it EOR, I think it's sort of a joke, but they're pumping surfactant. They're just bullheading it down these wells. And we don't even know where it's going, right? And they're looking at the production results, and they're trying to understand why some of the wells are responding to the surfactant and they're getting increased oil rates, and why some of the wells aren't. And I've heard nobody talk about what we just mentioned, like trying to throw this stuff into a machine learning model, not necessarily an LLM or a logistic regression model, but maybe one of these TensorFlow things, right? Where, you know, here's all the variables that we have that we can put in there, and then here's the result of the well, and it's going to have to be, you know, something that's kind of binary of, yeah, we got a good uplift, or yeah, we didn't, or some factor from 0 to 1, like we got a 30% uplift or 100% uplift, right? And then see if you can, you'd have to like reverse engineer basically, if you can understand what it is that some particular well is missing that caused it to not be favorable, right? And I don't, we'd have to talk about that for quite a while to figure it out. But I think the framework, just to prove up front, is show us if you can do this with just basic logs. If it works there, then it should work in other places. You know, we could push this and see what we can do with it. And, you know, if we can make it work, we can charge for it too, right? Which is good. So, you know, more work from Diamondback means we can charge more days per week, which means everyone makes more money, everyone's better, you know, happier. So think about that too, about, you know, this EOR thing and the CBL thing that we looked at with the water problems, producing water. All of these issues are the same, and they've been the same problems that we've been struggling with as oil and gas technical people for the last 15 to 20 years. Is you get all of this information and nobody knows how to figure out what's you know, what's causation, what's not causation, what correlates, what doesn't correlate. Nobody's able to do it because they're all working inside of packages like Spotfire, doing analytics, and nobody's got subject matter expertise over all the data domains. So that's just, in my opinion, like not the right platform to use. So maybe the right thing to do is to ask TensorFlow, right? Or something. Put all this stuff in there because people have been dumping on LLMs, right? That's normally that was the first thing that they tried, is they dropped the spreadsheets into the AI, into ChatGPT or whatever, drop all the data in there and say, you know, figure out why these wells are good and these wells are bad. And the LLM just fucking pukes, right? It doesn't know what to do. And it fails correlating things. Whereas, you know, using some sort of classification algorithm is much more strictly mathematical, right? And we're not relying on LLM to know what to do. And the TensorFlow thing, I've always kind of wanted to try that. It just seems neat to me, you know, like add data in there to create a synthetic image and see if the neural network can actually figure out what it is, you know. It should be able to, I would think. And I'll see if I can't get Diamondback to give us some data as well, that even if we do the project just for them, that's fine, right? And we can publish with them as well. But we need data, right? So think about it, I guess. Come up with something, you know, the EOR thing or the CBL thing or the well log formation tops thing. Pick one of those three to start with, and we'll get you data to start beating on it, you know? Well, there's so many problems with it, right? I mean, the first that I kind of snapped at these guys multiple times about is, you know, it's probably just that you're cleaning up the proppant pack, you know, and changing the relative, you know, proppant pack's going to have linear relative permeability curves, and that's easier to clean up because it's got linear curves, right? And that can make a significant change in production volumes. I don't think that you're pushing this surfactant into the fucking matrix at 200 nanodarcies, right? Like it's not happening. Do the fucking simulation work on that, right? Run a basic reservoir simulator, FVM 5 node, whatever, transmissivity and all that crap. Push the fucking fluid into the reservoir at the pressures that they're doing with the injection volumes that they got, and see how far that fluid went into the 200 nanodarcy matrix, right? If anything, you got like a less than a millimeter of fucking penetration around, you know, these fracture faces. So that's changing the game, and you're getting all this extra production from that bullshit, right? Not happening. If you're getting the production, it's coming from the rel perm change in the fractures. But I personally, I don't even know that I believe any of it because like you don't have any placebo, you don't have any tests to benchmark it against. Like, what happens if we just shut a well in and let it sit and then we turn it back on? Right? Who's to say that, with everything that's going on in these fields, with wells being fracked and pressure redistributing itself across these sections, I just shut a well off, turn it back on, I get a higher rate, just like that. And ultimately, the only way that you can claim victory is one of two things. One is that if you can prove that the rate increase that you got was due to the surfactant and not due to the shut-in. And the second is that if your EUR changes, if your EUR doesn't change, right, the ultimate recovery of the well is the same number of barrels, and all you did was just change the recovery time, then that becomes an economic consideration of time value of money, right? Net present value and all that stuff. It has nothing at all to do with whether or not the money that you spent on the surfactant and pumping it down the well. Like to me, again, my gut feelings have always served me well in my life, and I feel like this is sort of snake oil. Is not scientific, you know what they're doing, and they're spending millions and millions of dollars on all this surfactant and everything. But if I learned one thing in my career, it's that sometimes people know this, but they don't care. They still want something to advertise and put out, and like, we're doing this, it's working great for us. It gives us a competitive edge in the stock market and increases the value of our stock. So even though it might be baloney, phony baloney, not true, whatever, we're never going to admit that, and they'll never do the science necessary to prove that it's wrong because they don't want that to happen, right? Like, stop that guy. If he proves that our stuff is wrong, our stock price is going to go down. So, yeah. Why at Apache, that's what happened, right? When I worked there, we had a big prospect, huge, massive area in the southwestern part of the Permian Basin that, all the smartest people looked at, and all of us said, not good. This stuff is patchy. It's like there's no oil at all down there. It's all dry gas, to the point where you've got nitrogen and fucking shit like that, right? And heavily faulted area, very difficult to drill horizontal wells, repeatability on that. And the CEO said, I don't care, shut up. And they went and made this big announcement, and they hid all of the data. They had a special team that worked that area where everything was top secret, right? Nobody could find any of the well logs, and nobody knew any of the production data. Everything was kept secret from everyone. And they spent $5 billion on that thing. And in the end, we were all right. It was garbage. It was all dry gas. All the wells had really poor production rates. There was no infrastructure down there either. They had no pipeline, no processing facilities, right? So like, you can't, even if you get the gas, there's no way to get the gas out, So then they doubled down on their stupidity, and they formed a midstream company, Altus. And then they built all this pipeline and cryos and everything else to deal with the gas down there. And they lost a lot of money. Billions and billions of dollars was just wasted. And nobody ever got in trouble for it, interestingly. Even the CEO is still in charge, the same guy that did that. And it blows my mind. But yeah, people make bad decisions all the time. And it's usually because they're deliberately doing it. They know better, but they do it anyways. That's all about stock price and manipulating the stock price and all this stuff, Nobody cares about doing the right thing, which is the most efficient extraction of the resource possible. That's what I'm interested in, is getting the most oil out of the ground possible with the least amount of capital spent. That's what I want to do. That's what the engineer in me wants to do. And fundamentally, that's the best thing for the stock price because it means you have the maximum profitability. But that's not how the real world works because doing that is hard, but lying and making shit up is a lot easier. You know, like, oh, look, we pump fucking dish soap, Sunlight. We pump Sunlight down the well, and now we got 20% rate increase. That means we're going to increase our EUR by 20%. Value of the company goes up 20%. Boom. Best CEO in history, right? Look what I did. Anyhow, all right. Well, I'll let you go. Have a good, you're going to be off next week as well for the Monday through Wednesday. Is that right? Okay. So we'll see you on Thursday then.